Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 13, Lesson 3, Perimeter and Area of Composite Figures. The first thing that I think is pretty difficult here is understanding the word composite. It comes from the word compose. So I am going to pretend that I'm composing a song. And for me, when I compose a song, it often starts out with the lyrics or the words. Let's allow this rectangle to represent the words. And then I'd probably put a tune with it. Let's let this rectangle represent the tune. If I were writing a song, I would eventually get guitar chords for it so that I could accompany myself on guitar. These are the three different things that as a composer I might use to compose my song. And you can see how the rectangles are put together to make one big shape. Like this. Now it's all just one figure, but it has several different rectangles inside of it. So we're going to be using what we understand about rectangles and squares, which are also rectangles, to help us figure out these problems. Now to do that, we will rely heavily on some very specific properties of squares and rectangles. The first of which is that we know that if these lines are parallel to each other, and we know that because they meet at right angles. So if it's a right angle here and a right angle here, that tells us that these yellow lines are perpendicular to each other, especially if I put those right angles in over here. I am telling you that this is a rectangle, and you can trust it when the book puts in those little right angles for you. Now, because these are apart from each other and they're parallel, that means they are an equal distance apart, which means that this vertical line is equal in length to this vertical line. And of course, it also means that this horizontal line is equal in length to this horizontal line. So we can trust that when they set up problems like this, that they want us to use these very specific properties of rectangles to solve the problem. So our problem here today asks us, our first one asks us to find the perimeter of this composite figure. We can tell from how it's drawn and all those right angles that it is composed of many rectangles. Now, I've actually tried to record this video many times, and I've learned that having two copies is good because I'm going to make a big old mess. So they're exactly the same picture there. Now, to find the perimeter, I need to tell the entire length of every outside edge here. And the book starts by giving us some information about that. So I'm going to write down the ones that come in black first. I'm going to make sure I have 8 feet, 3 feet, 3 feet, 3 feet, and 2 feet written down. And there they are. But the problem with finding the perimeter of this composite figure is that there are several different edges that I don't know the length of. So how can I find those out? Well, first I'm going to use what I know about rectangles, and I'm going to divide this along vertical lines right here into 3 different rectangles. I'm going to call this one rectangle A, this rectangle B, and this rectangle C. And by dividing it into those parts, I believe that I can figure out this length, and this length. How are you going to do that, Miss Foster? Let me grab a green. So here we go. If this right here, rectangle A, is 8 feet long and 3 feet wide, or I could say 8 feet wide and 3 feet long, then I know that this edge down here will also be 3. I also know that this edge right here, if it's 10 feet all the way across, then if I take 3 right here and I take that away from 10, I will find out this length. So 3 minus 10 equals 7. Also, I know that if I take this length right here, and this much of it right here is 3, just like it is up here, then this length right here will be 7 minus 3. So now I know these 3 horizontal side lengths, and I'm going to write them down so I can add them to my black ones. And there they are, 3, 4, and 7, 3, 4, and 7. Okay, I divided it up vertically into 3 different rectangles, to help me find the horizontal edges. Interesting. I'm going to divide this up horizontally now to find out the vertical edges that I need to know. They are this edge here and this edge here. Those are the two ones that I need to figure out. So I'm going to go ahead and divide this up into these, yes, just like that, into these 4 different rectangles. And this one up here, do you notice it is a special kind of rectangle? It is a square. So I know that this is 3 feet right there. I'm going to grab my blue pen real quick. Blue pen, there we are. If this is a square, then won't this vertical distance right here be 3 also? I believe yes, because we can take this big long rectangle out of it, and we'll be left with 3 plus 2. That means also that this part right here is 3, and that all of this right here will be 6. Now, one mistake I just made on my last recording is I wrote this 3 instead of that 6 for the whole thing. So I'm just going to cross this out so I don't make that mistake. 3 for right here, because if I take this 3 and this 2 and I take them away from 8, then this will also leave 3. Oh my goodness. Let me write those down for you and then we'll add them all together. And here they are. So now, my friends, I finally know all of the side lengths, and that means I can get around to adding them all together and finding out the perimeter. Now, this right here is a mess that we call column addition. And whenever I'm adding a whole line of different addends, which is the word for every number you're adding, I like to hunt for friends of 10. Because I know that if I have 10 in the single ones place, I can regroup them into a 10 that's in the tens place. Sorry, when I'm looking at myself, I look like my mirror image, so I get a little confused about direction. So in this long list, if I can find a group of 10, I'm going to cross them out and just regroup. And here I see an 8, and I know that 8 plus 2 is 10, so I'm done with those 2 addends. Ooh, here's a 7, and right close to it a 3, that's another 10. Just doing my regrouping step by step. Here's a 4, and right below it, a 6. That's a 10. And all of a sudden, I find that I have 1, 2, 3 threes. 3 times 3 is 9. And oh no, I have to squeeze it here. But luckily, I'm using my smartboard program so that I can move that up a little bit for you. So we've got a 9 in the single ones place, and we've got 3 in the tens place for a total perimeter of 39 feet. Whoa, that was hard work, don't you think? Let's take a look at another one. So that was how I would tackle a perimeter problem. This is how I would tackle a problem with a composite figure that we need to know the area for. So I have some missing sides here, and I can make some decisions. I could cut it up like that and use a vertical line to cut it into two rectangles, or I could go across like this. And both of those ways would get me to the correct answer. For me, I think I'm going to go ahead and just do this one because I feel like it. That means I have rectangle A and rectangle B. Now, when I'm trying to figure out area, I'm interested in finding out the two-dimensional space that is covered by each rectangle, and I would use this to find out how many tiles to lay on the floor, how much carpet to roll out, something like that. So let's look at rectangle A. I know that from here to here it is 14 meters. And I also know that this right here is 7 meters. I can use multiplication to find out that 14 rows of 7 in every row would be, let me see, 7 times 4 is 28. And 7 times 1 is 7, plus 2 more tens is 98. So I know that the area of A is 98 meters squared, or square meters, which means I've got that little exponent up there. Tell me, exponent, that I'm going up and down and side to side, two-dimensional measurement. Now here I've got a bit of a puzzle. I know that this side is 8, so I'm definitely multiplying something by 8. But I'm not sure how big this is. But wait, I can use this 9 and this 14 to help me out. So 14 minus 9 would leave this distance right here, and that is 5. Then I can figure out that 8 times 5 equals 40. And so now I know that the area of rectangle B is 40 meters square. To find out the square feet of the entire composite shape then, I'm going to add together 98 plus 40. And to do that, just give me a moment. You've known how to do this one. Oh my goodness, probably since second. So my mathematicians, you don't know this, but I'm going to tell you that I have tried to finish this video 4 times now, and I keep running out of time. So I'm going to end this video right here and call this lesson 13-3A. And I'm going to make another video showing you our last problem, which does both area and perimeter for the same composite figure. Whew, it's a lot of work. So I hope to see you at the next video. You'll want to watch that before doing the workbook pages for this lesson.